So in this lesson, we're going to talk about topic 3.3, derivatives of inverse functions. So in this lesson, we're going to actually explore 3 different ways to find the derivative of an inverse function. Once we look at these different approaches, the goal is for you to understand how derivatives of inverses work regardless of what representation you are given in the problem. So this first method leads into what we saw in Algebra 2 with finding the inverse of a function. So these are the steps that we actually did in Algebra 2 to find the inverse of a function. So we started by switching the x's and the y values, and we solved it for y. Then we're going to put the calculus spin on it. Now we take the derivative of the new y. That's going to be the derivative of the inverse function. And then we're going to plug in whatever point that they give us. So let's try that a couple of times. So let f and g be the inverse functions, where f inverse equals g of x. If f of x equals x cubed minus 1, we're supposed to find g prime of 7. So this is the indicator, hey, g is the inverse, right? They told us that. We need to find the derivative of the inverse. So the instructions are right there, and then we evaluate it at 7. So I'm going to start by pretending this is a y, and I'm going to swap x and y. So x equals y cubed minus 1. Then I'm going to add the 1 to the other side, and I'm going to take the cubed root of both sides to get rid of the cube. So I get that y equals the cubed root of x plus 1, which really, if I start in function notation, I end in function notation. We also know that this is equal to g of x because it told us that right here. Okay. Now I have to take the derivative of that. So I know I'm making a huge equal sign here, but I'm going to rewrite it as that. Technically, we have a chain rule, but the u on the inside is x plus 1, so the u prime would just be 1. So it really doesn't matter if I invoke the chain rule on this one, because it would just be multiplying by 1. All right, so let's do the derivative of that inverse. So g prime of x equals, I'm going to bring the 1/3 in front. So 1/3 x plus 1 to the negative. When I subtract 1 off of it, I get negative 2/3. So I'm going to rewrite that one more time before I try to substitute anything into it. So I get 1 over, this whole thing goes downstairs. So 3 times x plus 1 to the 2/3 power. Now I go back to my instructions. I have the derivative of the inverse. Now I need to plug a 7 into it. So g prime of 7 equals 1 over 3 times 7 plus 1 to the 2/3 power. Now, if it was open-ended, you could leave it. This is likely a multiple choice, so we're going to have to simplify that. And it'd be a multiple choice without a calculator. So 7 plus 1 is 8 to the 2/3 power. And hopefully you recognize that 8 is the same as writing 2 cubed, which means I can use some of my exponent properties and cancel those cubes, the 3's. And we get 3 times 2 squared. And then 2 squared is 4. And 3 times 4 would make it 1/12. All right, we're going to do one more here. So we're going to look at example 2. We're going to use the same method, okay? So I am going to start by swapping my x and my y. So my y right now is this. So I'm going to say that I have x equals e to the 2y. I need to solve for y. We know that we get rid of an e by taking the natural log of both sides. So that would cancel there. So we get natural log of x equals 2y. To get the 2 to the other side, I either divide by it or I multiply by 1/2. Remember, if it starts in function notation, it ends in function notation. So f inverse of x equals 1/2 natural log of x. Now, it says I have to find the derivative of it at 3. They formed the question a little bit differently. So I'm actually going to take the derivative, and they usually write it like this, of the inverse function. So the 1/2 is going to stay. The derivative of natural log of x is just 1 over x. I could rewrite that as 1 over 2x, and now we're going to plug a 3 into it. So f prime, F inverse's derivative at 3 equals 1 over 2 times 3, which equals 1 over 6.